The distant past. Okay. So, this is an analogy. What is life turns out to be a really difficult question to answer, and this is how biologists usually answer it. They come up with a list. All right? But a list is not a definition. So we'd like to have a more elegant definition of life. This is the same problem that chemists were in 200 years ago when they were trying to figure out what is water. So, if you didn't know any chemistry, how would you describe water? That's chemistry. Hydrogen and oxygen is chemistry, right? Well,
Fluid?
pardon? Fluid. Liquid. Sure. What kind of liquid? What details would you add to that?
That can change with temperature?
Can change with temperature. Yeah. So if I put a liquid in front of you and said, is it water? Took it away. I added something to it. I put it back. How would you tell if it's water? I bet you have some, yeah. You look at the color, right? And if it was water, you'd hope it would be colorless. Right? Although you probably would recognize that muddy water is still water,
Yeah.
or that lemonade is still mostly water, right? But you'd like your water to be colorless. What else would you like it to be?
Odorless.
Odorless. Yeah, if it smells funny, you're not convinced it's just water, right? So here's a list that they were coming up with in the beginning of the 1800s. It's going to resemble what we just did, right? Water's clear, it's wet, it has that wet feeling, versus oil, which it could be liquid, but it's not going to have the right feeling, right? So you want to separate those, and again, we recognize that water isn't always clear. Water sustains life. There's a great thing about water. But of course, if you just give somebody water, they're going to die, and a lot of foods sustain life, so again, that's helpful, but not necessary and sufficient, right? And water can be deadly. Right? We see that any place where there's not a good sanitation system, don't drink the water. In fact, that's probably one of the reasons why we watched the video about this, right? Why learning to domesticate livestock and being able to drink milk saves so many lives. Because milk is safer than water in many parts of the world. Okay, so as Dahlia said, water freezes when it gets cold. It does things like soak into wood, flow downhill. So we got a list of characteristics of water just like we have a list of characteristics of life. Right? That's where they were in the 1800s. They had this list. But none of those were both necessary and sufficient. You couldn't say, it met those two criteria, so it's water. Just like you can't actually do that with any of these either. You can't say it met those two criteria, so it's life. Okay, so the true essence of water couldn't be captured until we learned some chemistry, and then we learned water's H2O, right? And then that's the definition of water. Although none of us use it in our day-to-day lives, right? If there's something mysterious in here, I don't have an H2O test kit. I'm going to use my senses to see if it's safe to drink or not, right? So I kind of think it's great that, you know, if I ask a class, what's water, they'll all say H2O, even though that's not what any of us do in our day-to-day life, if we're trying to figure out if it's water. We use the old criteria that the chemists were using 200 years ago, right?
We also didn't add that it's a solvent. You know how
Yes, it's a universal solvent, and that's actually a great feature of water. And you could add that to this list, right? And that's a really important characteristic of water. Okay. So, some people argue we're in exactly the same position when we try to define life, right? We have this list, but none of the things in the list are both necessary and sufficient. Maybe there's some central idea, the equivalent of chemistry, that we're missing. And some people think they know what that idea is. Something called emergence or emergent properties. There used to be a nice little video from Nova about this, but Nova took it down, and now it appears and disappears randomly on YouTube, as anything that's been taken down by its main site does, right? But if you want to learn more about emergence than what we cover here, it's a really good little video. the last time I went tracking it down, the quality was so poor that I don't want to try to play it for you guys, because it's the pirated 10 times one that showed up. But emergence is actually the idea that relatively simple rules that control interactions between parts can lead to really elaborate things. And we can see emergence with things like wind going over sand. Wind is just energy, sand is just sand, but when wind goes over sand, you craft it into really elaborate shapes and dunes, right? That is the emergence of a pattern from some pretty simple rules. Sand tends to fall to where it's most stable, and wind tends to push it. You get those rules, you get sand dunes. The NOVA video talked about early computer intelligence experiments where they try to get a machine to play checkers, and the machine learned well enough that it could beat the guy who programmed it, right? So they gave it simple rules, how to play checkers, but what emerged was a higher level of competence than human. Right? That's pretty cool, right? So emergence might be the key, and at the fundamental level, what it's telling you is that just having the parts isn't enough. A live cat and a dead cat have the same parts, right? Life emerges as energy flows through the living cat. So there's something about energy causing the parts of the cat, the molecules and the cells, to interact that gives the cat life. So maybe emergence is the key. People are trying to get to the physics of emergence and write equations for emergence, and they haven't yet. Right? Maybe that's the key to life. Okay. So again, an emergent property arises from interactions between molecules within cells or between cells. That would be how life would emerge, right, as an emergent property. But for that to happen, you have to have energy. That's kind of cool. That's a way of trying to break down what life is. So then death is the energy no longer flowing correctly, right? Okay. So energy flow and parts. That's how you study life, according to this model. And that's pretty much what we've done in this class, right? We've looked at, well, different types of life more than, our parts were all cellular. We didn't go into organs and tissues much in this class. But we looked at the parts of a cell, and then we looked at energy flow and outcomes from it. Okay. So, great. Maybe emergence is the key, but in the meantime, we need to define life. We need to define life for a couple of reasons. It would be nice to know when somebody's really dead or not. That's actually a big problem, right? And you can hear periodically legal consequences of this when the family says our family member is not dead and the doctors say your family member is dead. That's a problem, right? And it goes through the court systems to see if they should unplug the person from what's keeping them alive, because the doctors say they have no chance of recovery, and in many cases the family will say, oh, a small chance is still a chance, right? That's a problem. So we need to define life there, to define death, because they're two sides of the same thing. But we also need to define life if we're going to look for it on other planets, right? So we have a probe now that has landed on Mars, successfully landed last week, and it's going to be packaging up samples and trying to see if we can find things like organic molecules. It'd be nice if we could all agree on when we found life, right? So Hazen is a guy who's looking at the origins of life, and he says, it's difficult to be sure you've discovered life or deduced how it originated when you can't define what it is. Right? It's kind of a fundamental problem for everybody. Okay, so maybe black and white, live, dead is a false dichotomy from the start. Maybe there's going to be things in between. Right? Some people would argue viruses are that. Right? They're almost, but not quite alive. So NASA needs to recognize life on other planets, right? So they got a group of biologists together to define life. I'll show you a couple of their definitions here. This is not one of their definitions. This is something a Supreme Court justice said in 1964, but it's really apropos here. Anybody know what Justice Potter Stewart said, "I know it when I see it" about? It wasn't. It's suitable for that, but that's not what he said this about. Anybody know? It's pornography. I know it when I see it. It works just as well for life, right? Except when it doesn't. So the US Patent Office started us on the road of being able to patent genes when somebody brought some dried bacteria into them. And because it didn't move and it didn't look alive to them, they allowed it to be patented. That was the beginning of patenting genes, patenting life, which we still do, right? So in fact, if you send your DNA into Ancestry or DNA 23andMe, yes, they give you an analysis and send it back to you, but they have your DNA then. And they're actually sending it out to researchers, and somebody might patent one of your genes. You don't own your genes. That was basically what that Supreme Court decision came down to. Somebody can patent them. That was not exactly probably what the justices were thinking at the time, but they didn't understand that powdered bacteria just add water. It's alive, right? They didn't understand. Powdered things aren't alive. True. But it's not that simple, is it? Okay, so definitions of life. Any population of entities which has the properties of multiplication, heredity, and variation. That was one biologist answer in NASA. Got some of the list, right? Good job. Right? That was one of the definitions, because cells can communicate. And so, if you can communicate, you're alive. A flow of energy, matter, and information. A self-sustaining chemical system capable of undergoing Darwinian evolution. Okay, so NASA actually got like hundreds of definitions of life out of scientists. But from this short list, they chose one that they're using when they look for life on other planets. Any guess as to which one it is?
The very bottom.
Very bottom one. Yeah, the one that includes Darwinian evolution. Right? So, really important idea. Right? Okay, so let's see why just for a minute. That's the one they chose. The definition that's being used by NASA right now when we're looking for life on Mars or anyplace else. So if you break that down, there's three important parts to it that are the reasons they chose it. Life has to be a chemical system that gives us all the carbon chemistry and the water and osmosis stuff that we talked about earlier, and it gets rid of electronic systems like computers. We're saying we don't think electronics are how life could arise on its own, right? And they're not saying that computers could not become self-aware, although some biologists think that's impossible too. But there's plenty of sci-fi about that. The entire Terminator series is about that, right? Not to mention Battlestar Galactica. So they're saying that's not life as we're defining it for a biological system. Yes.
So the evolution is really for us because, I mean, when a species was being different because of the environment, what if another planet, the environment has never changed, and that does not apply? Or
Okay, but natural selection is also necessary to keep you matching your environment, because mutations are going to arise, and you would change just because of the mutations without natural selection pruning you back to match your environment.
So it's a really mutation, not the evolution, because maybe the mutated cells will not survive in a new one.
Okay, so this is a good point. There were 5 causes of evolution. And people like to get this all confounded, right? Maybe remember the 5 causes of evolution? One of those 5? Well, yeah, natural selection, one of them. So that's the only one that causes you to be more suited to your environment. Natural selection is the only one that causes adaptation, and adaptation was a change in your DNA that made you more suited to your environment, a heritable improvement. Okay, what was another cause of evolution? Change in gene frequency, right? That's what evolution was, change in gene frequency. What was another cause?
Mutation.
Mutation, all right. So, mutations cause evolution, but they just cause variation. Without natural selection, the variation will not make you more suited to your environment. So, this was also related to that essay question about is evolution random, right? Mutation is random, but natural selection is random. You saw that natural selection favored black pocket mice any place there was black rock, right? So, evolution, some causes are random, some are not. And natural selection is really important because it's a non-random cause. What's another cause?
A mutation?
Of evolution. Random mating, yeah. Or actually, if it's non-random, it'll cause evolution. If it's random, it won't cause evolution. Right?
Wasn't it migration or?
Yeah, immigration, emigration. Gene flow, in other words. Genes leaving or coming in could cause a change in the genes, right? But it may not make you better suited. And then the last one was important too.
The size.
Yeah, large population. If you don't have a very large population, what happens? So the cause, let's see, not having a large population is going to cause evolution. Having a large population prevents it. If you don't have a large population, what happens? Do you remember? Genetic drift. The population would change just because the tree fell on the one blonde person. Right? Okay, so natural selection. Again, be careful that you realize that Darwin's theory is evolution by natural selection. Evolution has 5 causes. By natural selection is all the stuff Darwin's talking about. Because yeah, people get that confused all the time. Right? See that exams all the time. Like, no! All right, so let's see. Chemical system. That gets us, again, the first part of the class where we did chemistry, homeostasis. Metabolism, have to be able to gather energy somehow. That got us autotrophs, heterotrophs, ATP, all of that good stuff, right? And then, yes, natural selection, which requires variation, that is inherited, which requires something like DNA. Right? Because the only way you could have natural selection was to have variation that was inherited, and so that gets us through several other complicated ideas. So that's why they chose that definition. There's actually a lot in that definition when you unpack it. So maybe in the next year we're going to find evidence of life on Mars, right? We're not. But we're in a far better position than we have been with that new probe down there. And obviously that's very much what people are looking for as we man that probe. Okay, so we have 20 minutes. We can do some more review. Lab is all about invertebrates, because usually those are the ones that you haven't heard of, right? The vertebrates you've usually heard of before, so that's usually the easier thing for you to go home and study. And then the final is comprehensive. It covers the entire semester, but it's your only test on this diversity. So you might see a little more weight on diversity. It's going to cover